Okay, so this is the Leaving Cert Higher Level Maths Paper 2, 2022, question 9. Oscar is taking some measurements and is using trigonometry to work out some angles, distances and areas. First, Oscar takes measurements of two adjacent triangular fields, field 1 and field 2, as shown in the diagram, not to scale. B lies on the line AD, that's down here. And let's see, AB is 30, BD is 10, AC is 35, and CAD is 50 degrees. The angle ABC is not a right angle, so these are not right angles down here. Find the area of field 1 and hence find the area of field 2. Okay, so we're going to use our formula for areas of triangles here. So let's see, the area of the triangle is half AB sine C. So to find the area of field 1, so the area is going to be half of 35 times 30 times the sine of 50 degrees. Okay, so that is 402. And we're looking at meters, so it's meters squared here, and this is to the nearest meter squared. Now to find field 2, what I'm going to do is get the area of this big triangle here and then subtract field 1, and that will give me field 2 here. So it's the same kind of thing again. Let's see, the area of the triangle ABCD is going to be half of, let's see, 30/40 times 35 and then sine 50 again. So that's the area of triangle ACD, the big triangle. So that's going to be 536. Again, that's meters squared. So the area of field 2 is equal to 536 minus 402, and that gives you 134 meters squared. So this is our first solution, this is our second solution. I think that's all we had to do, find the area of field 1 and hence find the area of field 2. So there are two answers, 402 and 134 meters squared. Find the length of the perimeter of field 1, give your answer correct to the nearest meter. Okay, so the perimeter, we know that it's going to be 35 plus 30 plus this distance here. So how are we going to find this distance here? Well, we have two sides, we have an enclosed angle, so this looks like it's going to be the cosine rule to find this side here. So it's going to be this side squared is equal to this side squared plus this side squared minus twice 35 times 30 cos 50. So let's write all that out. I might just take that and move it up a little bit. So let's see, it's going to be the distance, okay, so the distance from C to B squared is equal to, let's get these numbers right first, so it's 30 squared plus 35 squared. So it's 30 squared plus 35 squared minus twice 30 times 35 cosine 50 degrees. So the distance from C to B squared is going to be 775.1460197. So that means then that the distance from C to B is the square root of that, which is 27.84, and that's in meters. So that means then that the perimeter of field 1 is equal to, we only need, let's see, give your answer correct to the nearest meter. So I'm going to say 27, let's just say 27.8. I'm just going to use there plus 30 plus 35. Plus 30 plus 35. And that's going to be 35, 45, 55, 65, 75, 85. That's going to be 92.8, which is 93 to, and that's meters to the nearest meter. Okay, that's it for B. Let's have a look at part C, just part C1. So let's see, we have Oscar, who is also watching an airplane P fly directly over his head. He is standing at the point O down here in the diagram. The x-axis is the horizontal ground and the y-axis runs vertically up from Oscar. The airplane P is flying at a constant height of 10 meters, so this is 10 meters up here, above the ground as shown in the diagram. Okay, sound travels roughly at a speed of 343 meters per second in air. As the airplane flies, its engine makes a noise. It takes some time for the sound to reach Oscar. Use the information in diagram 1 to show that it takes 41 seconds for the sound the airplane makes at P1 to reach Oscar correct to the nearest second. Okay, so looking at this diagram here, we can see this is a right angle triangle here. This is 45 degrees, this is 90, this must be 45 degrees here. So this here, if this is a 45 degree triangle, that must be 10 kilometers there as well. Because remember, the tan of 45 degrees is 1, so it's 10 over 10. Now, this here then must be 10 root 2. Now we can do Pythagoras' theorem. If you just think about it, if you have a right angle triangle like this, and if both these angles are 45 degrees and 45 degrees, let's say that's 1, this must be 1 as well, 1 over 1. So if you do Pythagoras' theorem, that's root 2. So if this is 10 and this is 10, well, this must be 10 root 2 here. But just to do it out for completeness sake, we have 10 squared plus 10 squared is equal to, let's call it x squared, so that's 200, it's equal to x squared, and then x is equal to 10 root 2. Now, the other way of doing that, of course, is to do cos, some of you may have done this, cos of 45 degrees, this 45 degrees here, we're going to use, so it's adjacent over hypotenuse, so the cos of 45 degrees is equal to 10 over the distance from P1 to O. So that means if you cross multiply and divide here, you get the distance from P1 to O is equal to 10 over the cos of 45 degrees. And you know that cos 45 degrees from your log tables, or maybe if you know it anyway, is 1 over root 2. So you've got 10 over 1 over root 2, so that gives you, just flip that upside down, you get 10 root 2, which is what we got up here. Okay, so all that goes to show anyway that this distance here is 10 root 2. So now we have the distance from P1 to O. Okay, so what do we have to do anyway? Use the information diagram to show that it takes 41 seconds for the sound of the airplane, makes at P1 to reach Oscar correct to the nearest second. So we're looking at speed is equal to distance over time here. So let's do that kind of thing. Okay, so we know that speed is equal to distance over time, and we were looking for time here, so that means time is equal to distance over speed. Now we have the distance, we just worked it out as 10 root 2. Now that's kilometers, so we've got to divide that by 343 meters per second, but we have kilometers on the top, so let's change that to kilometers, so it's 0.343 kilometers per second. Now, when you do that, what you're going to get is 41.23, 41.23, and so on. Seconds, remember we're still dealing in seconds here, so that's to the nearest second is going to be 41 seconds. Okay, so that's all we have to do. Show that it takes 41 seconds for the sound the airplane makes to reach Oscar corrected in nearest second. So we've done that. Okay, so let's look at the next part then. So we have the airplane that is flying at constant speed. Okay, so the airplane P is flying at constant speed of 255 meters per second. By the time Oscar hears the sound the airplane makes at point P, the airplane has flown on to point P2 as shown in diagram 2 above. Work out the size of the angle, mark theta in the diagram 2, correct 1 decimal place. Okay, so if we look at our diagram here, the airplane has flown, by the time the sound has actually gotten from here to here, the airplane has flown from here to here. So we've got to work out this angle here. So what we know here is, we know that this side here is 10 kilometers. If we can work out this distance here, we can use tan of this angle here to find the angle. So let's see if we can work this distance out here. We know that this is 10 out as far as here as well, by the way. But let's work out the total distance from here to here. So we know that it takes 41 seconds to get from here to here. We know the speed the plane is traveling at, so we can find the distance. So let's do that. Now, again, speed is equal to distance over time. This time we are looking for distance from P1 to P2. So what we're going to do here is go distance is equal to speed times time. Now the speed that the plane is traveling at is 255 meters per second, so that's 0.255 kilometers per second, multiplied by the time we worked out is 41 seconds. Now I'm going to use the rounded time here. This is what we were given in the previous section. I'm assuming that that's what we're going to use because they tell us in this part of the question that it's 41 seconds. Now, if someone couldn't work this out, if someone didn't know how to do this, at least they would have this time here. So I'm assuming this is the time they want to use down here rather than the accurate version here. Okay, so let's use that then. And we have, when you multiply those two, the total distance, then when you multiply those out, is 10.455. 10.455 kilometers. So that means the distance from the vertical to P2 is 455 meters. In other words, the distance from here to here is 455 meters because we know that it's 10 kilometers from here to here and it's 0.445 from here to here. 0.455 I should say. So that means we have our small triangle like this over to P2 and down along here. I've drawn it a bit bigger than in the diagram. This is our theta here. This is a right angle here, and this is 0.455 kilometers along here. We've got to work out this angle. So let's do that. We know this is 10, by the way, 10 kilometers here. So we're going to use tan of theta is equal to the opposite, which is 0.455 divided by 10. So that just means then that theta is equal to tan inverse 0.455 over 10. So we've got to work out theta to 1 decimal place. Okay, so when you do that, you're going to get 2.6 degrees to 1 decimal place. Okay, and that's it for part 2. Let's have a look at part D then. So P3 and P4 are two other points on the flight path, so that's these two here, same airplane. By the time Oscar hears the sound the airplane made at point P3, the plane has flown on to point P4. So the sound has gone from here to here. As soon as Oscar hears it, the plane is now over here. So we have this isosceles triangle here, because D is equal to D here. Let's see, P3 and P4 are both a distance of d from the y-axis, so we have these two d's here as well. Explain briefly why the following equation holds. Okay, so we have this here, looks like some kind of a Pythagoras theorem. This is a speed of sound, this is the speed of the airplane, and this is the distance. So this is distance over speed, distance over speed. So what we're looking at here is the distance the sound makes from here to here, divided by its speed. That's going to also be equal to the distance that the airplane makes from here to here, divided by the speed. So this is actually the time the sound takes to get from here to here, and this is the time that it takes to get from here to here, and both times should be the same, because remember, the sound that Oscar hears, as soon as he hears it, the plane has moved from here to here, so both these times should be the same. So look, there's any number of ways of explaining this. Let's see. So let's start with the time sound takes to reach Oscar. So that's equal to distance over speed. The distance is going to be the square root of 100 plus d squared divided by 0.343. So this is the distance from P, I think they call it P3 to O, divided by the speed of sound. So that's what we're talking about there. Okay, so the time the airplane takes to go from P3 to P4 is equal to, again, distance over speed, which is 2d divided by 0.255. So I'll just put IE here, just see what I'm doing. So this is the distance the plane has traveled, divided by the speed of the plane. So, you know, you can say both these times are equal. Since the time it takes the sound to reach Oscar equals the time it takes the plane to go from P3 to P4. Okay, so look, I could keep going here, but I think that's a sufficient enough answer there, okay? Let's have a look at the next part of the question then. So now we've got to solve the equation above to find the value of d correct to one decimal place. Okay, so our equation was square root 100 plus d squared divided by 0.343, and that was equal to 2d over 0.255. Okay, so let's start then. We're going to start by cross multiplying because we've got a fraction equal to a fraction. So 0.255 times the square root of 100 plus d squared is equal to twice 0.343, so that is 0.686. Now what I'm going to do next is square both sides. So if I do that, I get 0.065, 0.065025 times 100 plus d squared is equal to 0.47059 6 d squared. Let's just multiply out this bracket. So multiply this by 100, you get 6.5025, and here we're going to get 0.065025 d squared is equal to 0.470596 d squared. Okay, these numbers are not very nice to look at, but anyway, let's just bring this one over here. So this is 6.5025 is equal to, we got to subtract these two. So on the right hand side then I should end up with 0.405571 d squared. Divide across, so that'll give me d squared is equal to 16.03295107. And finally then we just need d here, I think it is. So we just got to get the square root of this, and that is, we've got to do this to one decimal place, so it's going to be it's actually just 4.0. It's d, so it's going to be in kilometers, and that's to one decimal place. Okay, and that's question 9 finished.